Welcome to the Math Record. Today we will learn about composite functions, one-to-one functions, and inverse functions. This video will cover part 2 of chapter 3 in our Precalculus class. Okay, first off, let's learn about composite functions. So what is a composite function? A composite function is basically putting one equation in another. So basically, let's say you have equation f of x is equal to x plus 1. And you have another equation called g of x, which is equal to like x squared plus 2, right? A composite function would be like f of og. They usually use a circle. But what it really means is just f. G of x is inside inside f of x, basically. So what you do is that you plug in this equation into x. So this would become the new x. So x squared plus 2 plugs in for this x over here, and then you add the 1. So f of g of x is equal to x squared plus 3. The same case could be applied if you put g o f. It was g circle f. So basically, that would basically mean g of f of x, which is equal to plug in f of x into this. So it'll be x plus 1 squared plus 2, which expands out to x squared plus 2x plus 3. So these are basically what is called a composite function. So that's the first part about it. So what the class usually asks for, or these types of questions ask for, is they ask for the domain and they ask for the range. So once you plug these equations in, you just have to find the domain and the range. So you just look at this. This is x squared plus 3. So technically, this could go from negative infinity to infinity. And this equation could plug into to go to infinity in negative 0 to infinity. To infinity. I mean 3 to infinity. This is a quadratic. Basically. That's how it works. There is some limitations though. So let's just say like one of our equations is f of x is equal to like square root x, right? And you want to plug this into this equation. So you put f of g of x. So this would be our new f. We're going to have this into here. So that would just be x plus 2. The domain right here is only 0 to infinity. Because you can't have a square root negative. But as this is 0, that means this has to be 2 to infinity. You see how that works? Even though it looks like it cannot, but this starts at 2, yeah, because this is square root x, and this is linear. So you have to, as you have these domains, you have a domain here. So the domain is restricted, basically. Oh, sorry, I wrote the wrong one. It's g of f of x is equal to x plus 2. So the domain is still the same though. It's 0 to infinity. Well, you include the 0, and you have you include the 2 to infinity. So that's basically how you do it for composite functions. And now one-to-one functions. One-to-one. Let me write this out first. One-to-one functions. One-to-one functions are basically functions where each y value has a particular x value has a particular y value. So what does that mean? So basically, if you look at a linear equation, you see how every single y value has like a particular x value? That's basically what it means. This is a one-to-one function. But you have something like this, a quadratic, it is not a one-to-one function because you can see overlap, basically. So what you have to do is that if you just draw a graph, doesn't matter how it looks. If you're gonna use something called the horizontal line test. So what you're gonna do is that if you draw a line through like the graph, it cannot go through multiple points. It can only go through one point. If it goes through multiple points, it's not a one-to-one function, basically. So that's how you tell if it's a one-to-one function. Just use the horizontal line test. So if you know how it looks, just graph it on your calculator, and you just and you see that like a graph had multiple points we could go over, then at any point, at any time, it's not a one-to-one function. But there are a graph that looks like it's going through multiple points when it really isn't. So it looks like this. It looks like it's going through multiple points, but it really isn't. It's just slowing down and then slowing back up and then increasing again, right? So that's basically what it looks like. This is a one-to-one function. It's like at no point during the graph that is like it's going through more than one point, even though it kind of looks like it is, but it really isn't. Okay. So that's one-to-one functions. And the last function we're going to cover, which is the most commonly used, is called the inverse functions. These functions ask, basically, if we draw an equation right here, right? If we draw an equation like this, what would the inverse look like? So it's trying to like reflect it across this line, like this line called y equals x. So this is a linear line, and you have this equation. Like, how would this look? It will look something like this, right? This is reflected like a mirror. Imagine this is a mirror. So how would we calculate that, though? There is actually a really easy way to do this. So for inverse functions, basically, if you have an original equation called y is x plus 2, right? You just switch the x and the y's. So you put x is equal to y plus 2, and then you only want to get the y, so you use y is equal to x minus 2. So that would be our inverse function. If you have something like, let's say a quadratic, right? And you have x squared plus 2, then you have to inverse this. You have x is equal to y squared plus 2, and then you minus equals y squared, and then you square root x minus 2 is equal to y. So how would this, and you have to draw this out. So you have an equation that looks like this, and you had to go through it has to be a mirror of this line, whereas y is equal to x, basically. So what's going to look like, it's going to be something like this, right? And you're going to only have the positive version. Usually it's only going to be the positive version, even though it doesn't look like it, it really is. But if you want to do it too, what you're going to have to do is that you're going to have to put the, in a way, you're going to have to put like an absolute value or something, I think. I forgot. But basically, that's what you're going to have to do. It's usually just going to be a positive version anyways. So it's got to be something like this. So that's basically what you do. You just reverse the x and the y's. So a neat trick about the notation to write, let's say the original graph is f of x. The inverse will be called f prime of x. Usually that's what they call it, I think. But a neat property about these graphs is that if you're looking for the domain, let's say the domain is 0 to infinity, right? And our range is like 2 to like 5 or something. Then our domain here is got to become the new range. It's going to be 2, 5. And the range here will become 0 to infinity. That's how it usually works. It reverses the domain and range. So the domain of f of x will become the range of f prime of x, and the range of f of x will become the domain of f of x. You see how they switched? Yeah, so that's how it works for inverses. So those are the basic properties you need to know for a inverse, composite functions, one-to-one functions, and inverse functions. Composite functions won't be used as much until you get into like maybe higher levels of like pre-calc, but they're gonna be use composite functions a lot during calc, which will cover the series later on in the future. OneToOne functions, they're pretty important. I've seen them in the SAT before, or the subject SAT. So you might want to learn that. It's really simple. You just need to use the horizontal line test, and you find out it's a 101. But you do need the picture though. And then finally, inverse functions. This is used really commonly across many subjects. So just learn your inverse functions, which is really simple. Just reverse the x and y's. Just switch them. So you have y is equal to x. Then you switch that as x is equal to y, which is the same thing. So you have like y is equal to 2x squared plus 3. Actually, let's make this a little bit more complicated. You have y is equal to 2x squared plus x plus 3, right? You switch the x and the y's. X 2y squared plus y plus 3. And then you kind of like distribute out the 2. You got y squared plus 1/2 y. Actually, let's make this equation a little bit easier for me. I want to make it factorable. So it'll be like y is equal to 2x squared. 8x plus 8 or something like that. And you switch the values. 2y squared plus 8y plus 8. And you kind of, sorry, it's getting cut out there. I'm running out of space. You kind of divide by 2 from both sides. So your x divided by 2 is equal to y squared plus 4y plus 4. And then you get like x squared is equal to y plus 2 squared. And then you square root the entire side to get y plus 2. And then you kind of just subtract that 2 from both sides to get equal to y. So that's what you get. So that's how you do it. So just substitute the x with y and y with x. And then rearrange it so you get just y on one side. Or you can just leave it and you just play your equation based on that. It would technically be an inverse 2, but it's not the proper form. Anyways, thanks for watching, and I'll see you at the next math record.